Dr. Iketa, welcome. It is wonderful to get to talk to you. Please introduce yourself and tell us, what is TRISH?
Absolutely. My name is Emmanuel Riquera, and I'm the Chief Medical Officer at the Translational Research Institute for Space Health, and I'm also faculty at Baylor College of Medicine in Houston, Texas. The Translational Research Institute for Space Health, or TRISH, we're partners to the Human Research Program at NASA. And one of our main goals is to find and fund new disruptive research that is high risk but potentially high reward, with the end goal of keep humans healthy both in space and on Earth. And we have been working with commercial spaceflight missions since last year, and Axiom 1 is our fourth commercial spaceflight mission.
That's really fascinating. Can you tell us a little bit more about your primary areas of focus or what you're studying on this mission?
Yeah, so TRISH focuses mainly on the high priority areas of human spaceflight research. And I would say the three highest priority areas are radiation, behavioral issues that come from being isolated and confined in space. And the third one is how your body changes while you're in a different gravity field, either a zero-G environment like in space, or during different gravity fields when you are in the moon or Mars.
Okay, interesting. So what kind of systems or hardware are you working with specifically to capture this data?
For this mission, the hardware that we're using is absolutely optimized to provide, number one, the highest quality data, while being still easy to use, easy to implement, and being the lowest burden to the astronauts. So to collect all of this data, for example, vision changes, we have been using a small device, is roughly the size of a shoebox that you can see here. I have this here with me. So this is basically like having an optometrist on a box. Basically, the only thing that you have to do is just grab it, put it on your eyes, look at an object that is roughly 6 feet away from you, and after a few seconds, you get a prescription of your glasses as right here. So as I was saying, if there's any changes on astronauts during these missions, we'll be able to see how that changes with this device. We're also looking, I was mentioning, at behavioral changes, how being in an isolated and confined environment has any behavioral aspects. And for this one, we have been using a small tablet like this one, also to test the sensory motor adaptation, the balance disorders, and the space motion sickness. We're using a device like this. And for each of the crew members, we have a set of hardware like this, and it fits. The four sets of hardware fits on a medium-sized suitcase. So it is really easy to move wherever it needs to go for launch and landing.
That's wonderful. So what are some of the intended outcomes or goals of the research you're doing?
Yeah, so some of the outcomes and one of the main applications, number one for spaceflight that we want to get from this research is that short duration missions like Axiom 1 are very, very relevant in the context of Artemis missions. When we go back to the moon, the first missions are going to be roughly the same duration as Axiom 1. So anything new that we learn from these missions is going to be absolutely valuable. Really, every new piece of data that we collect in spaceflight could potentially solve and be that last piece of the puzzle that we're looking to complete what we need to know.
Well, Dr. Iketa, thank you so much for speaking with us today. We wish you the best of luck.
It is my pleasure. Thank you.